Okay, the second question is a series question. And we're asked to use the formula for r squared and r to show that the sum from r is 1 to n of 6r minus 3 all squared is equal to 3n bracket 4n squared minus 1. So the first thing to do, we need to expand 6r minus 3 all squared because we need it as a polynomial. Okay, so I get 36r squared minus 36r plus 9. So now I can sub in my formula for r squared and for r and take care with the 9, because if you've got a single number, you would then get 9n. So if the number was 15, you get 15n. That's a common thing that people miss that off. Okay, so I've subbed my values in and you can see my work solution, so we'll just go through it. So I've subbed in here the formula for r squared. To help me differentiate between these brackets and the fact that I've got 36 of the whole of this, I've used square brackets. So it's 36 lots of the formula for r squared minus 36 lots of the formula for r plus 9n. Right, now if you look at the question, it is telling us what to take out. We know it's a 3 and we know there's an n, so just if it's clear what you take out that factor, and then the bit inside will work itself out. Don't try and foresee what's going to happen, because you won't. You just need to go for it and it will become apparent as you work through. So here I've just, first of all, before I do that, actually I've just simplified. So 36 is 6, 36 halves is 18. So now I've got the terms like that. So I've taken 3n out. So 3n from here would leave me with, I need 2 more, and then I've got both my brackets. Here I've got minus 18n, so I need minus 6, and then my bracket there, and then 3n times 3 would give me the 9n. Expanding everything in here, simplifying it. When you work through that, you'll see something lovely happens. You'll see that 6n cancels with minus 6n. You get 2 minus 6 plus 3, which gives you a minus 1. So you're never going to spot that up there. I'm not going to, you're not going to. But I've got what I need outside, so that has to be right. If you've subbed these in right and you've worked everything out right, this has to be able to give you this at the end. But obviously you need to convince the examiner. You can't go from that to that, you won't get the mark. Right, for part B it says hence, so that's going to tell me that I'm going to have to use the bit from the first part. Hence express this as a product of 4 linear factors. So if you see, this part here is what we've just done there. So I know that this is equal to this. If you've not managed to do part A, you can still have a go at part B, because we know that's the answer, because it's a show that. So I need to look at this part. What does this mean? Well, it basically, instead of going from r equals 1 to n, it goes from r equals 1 to 2n. So all that means is, instead of subbing n in, like normal here, whenever we've got an m in my r cubed formula, I'm going to sub in 2n. Okay, so the formula for r cubed is a quarter n squared n plus 1 squared. So for n squared, I'm going to sub in 2n. Now you've got to make sure, and this is a common mistake, it's the whole of 2n squared. It's not 2 lots of n squared, it's 2n all squared. Because that expanded then will give me 4n squared, which is different. And then my n plus 1 squared, well, instead of n, I'm going to put 2n, so that's what we get. So combining this now with the result from part A, we get this. And then we need to think about what the question's asking. So the question's asking to write it as a product of 4 linear factors. Okay, there's different ways to go about this. There is it is possible to expand all this out, simplify it all, end up with this quartic. When you get to the quartic, it's easily noticeable that they've all got an n in, so you can take that n out to give you one of your factors straight away. Then you're left with a cubic, which you should know in understanding the word polynomials from core 1, be able to find a factor by subbing in a value and getting it equal to 0, giving you the factor, working out the quadratic, but it's so long-winded. So it is possible to do it without spotting this, but the key is, and something that I would always ask you to keep an eye out for when in any aspect of your maths or your further maths, if you're asked to write something as factors, Or actually, when you're doing a lot of the work with the trig identities, to just be on the lookout for the difference of two squares. And you'll see here that that is the difference of two squares. 4n squared minus 1 can be written as 2n minus 1, 2n plus 1. If I can write that as 2n plus 1, I've got a 2n plus 1 there. So that's the kind of thing that we're spotting. So they'll both have that in common. What can I do then? Okay, so what I've done here is I have expanded that to get 4n squared, so then my quarter and my 4 have cancelled, leaving me with n squared, and I've written my n plus 1 all squared as 2 brackets there. I've written down my 4n squared minus 1 as the difference of two squares, so if you just check 2n times 2n is 4n squared, plus 2n minus 2n would cancel, leaving the minus 1 there. The way of spotting the difference of two squares is you need a square number there, you need a square number here, so because n is squared and 4 is a square number that would work, and you always need a minus in the middle. Alright, now, so you can see I've got an n common there and an n common there, so I'm going to take that out. With both of these I've now got 2n plus 1. Left from this term I'd have an n and another 2n plus 1. From here I would have a minus 3 and a 2 and minus 1. Expanding all this out and sorting it out, we end up with this quadratic, which will factorise into this, leaving me with 1, 2, 3, 4 linear factors.